So before we get into the animation part, I'm just going to quickly go over a little project that Rob's working on and kind of give a little bit of my take on it. So let me share my screen, desktop 2.
Hey, Tim?
Yeah?
I'm driving right now. I'm about home, and then I'll go upstairs to my computer. So if I don't chime in, if you ask me a question, it's just because I'm transitioning.
Okay, no worries.
All right, bye.
Bye. Okay. Let me, here. So is my screen visible to you guys?
Yep.
Okay. So Rob's making these elephant piggy banks for the Christmas gift exchange or Christmas gift sale. And what you see in the bottom of the coin cavity is a slot that needs a plug. So Rob made this plug initially, and his question was, how do I curve this to fit into the curved surface? So if we look at the pig, this surface on the bottom has a slight radius to it. Well, let's take a look at this picture here from the upside down part of the pig, or sorry, of the elephant. You can see there is a radius there.
Yeah, it looks like 3D print it and then just use a heat gun.
That's one way. The challenge is that inside of it, you have, oh, now we're starting to get a crowd. That's great. Inside of it, you have these vertical walls. They're not going to bend quite as easily. You could notch them, but hey, let's do it all in 3D CAD so that it fits in nicely. And so
is the elephant in CAD?
I don't believe that the piggy bank is in CAD. Otherwise, that would make it a lot easier to fit, because then you could try it and look at interference and get a nice, tight fit, etc. But what I did is I took some guesses. So this is the version that I made, okay? And I'll step through it. And hopefully Rob will be able to see this. But where I started, actually, let's get a full screen here. Whoops. That's on play mode, and I wanted to go on step mode. No, somebody's got some
ping pong
noise in the background. Might be Nancy. There we go.
Yeah, sorry.
No worries. So what I did was, first, if you look from the front, I made a profile, a side profile, so that I could get the radius here. And for the time being, this is flat and sitting on the XY plane. And I made it with the XY plane as my sort of center of symmetry for everything. The origin, sorry. Okay. So I, of course, started by setting up some parameters. And so I set up belly radius to be this radius here that we're trying to achieve. The cavity radius, I actually wanted the little tube walls inside to match the radius here of the coin cavity, which is much tighter and not concentric. I have the length of the, oh, that's something, yeah, the length and width of the slot, the coin slot itself, and then the length and width of the flange, the thickness of the flange, the height of the tube that's going to go up inside the slot, and the wall thickness for that tube. And then in some variants, I did a retention bump, depending on what kind of material you want to use. I did a couple of different designs just to kind of play around with it a little bit. But for the simplest design, I first made this curved, this profile that had the curved surface on the front of it. Put that down because I did record. Then I created a rectangle, and this is also created on the XY plane and coming straight up, and that's part of why I left this bottom surface flat for the time being. So that was just a simple rectangle, or two rectangles. The offset on the rectangles is the wall thickness, or what I called, I think, tube thickness. And then from the side, or from the front, effectively, I sketched this arc with the edges here, and I used the belly radius to drive this curve. Okay, so you see these radii are different and non-concentric. The next couple of steps are really kind of clean up. I added some radii. Then from the front, maybe I should turn sketches on. This would probably be this sketch here. So then I made a sketch from the front here using an offset from here, and chewed away the extra material we no longer want. Okay, so now I have the shape I want. And after that, it's mostly cleanup. A couple of radii, fillets on the corners, fillets on the top edge, fillet on that inside edge just a little bit. And I put a fillet around the inside just to strengthen that up a bit. I didn't put a fillet around the outside because that might interfere with the slot. And then I put a draft. So a draft adds an angle onto these surfaces, and that's effectively a taper on that rectangular wall, so that it goes in and creates a tight fit as you jam it in there. And then just to make sure that it would lead in fine, I put a chamfer along the top edge. Now, I'm not sure, did we lose you, Rob? Nope, we got you back. Thought you're on mute though.
Okay, I'm up here now. So this is exactly what I was asking, and looked like when you looked at the change parameters, when you showed us the parameters, that they were similar to the ones I sent you in the file, or almost the same in most cases. So I'm assuming that if you sent me this file, it would almost fit, and the only thing I'd have to adjust possibly is the radius you have here, but it'll probably work just fine as it was. So that's exactly what I was looking for, is how do you get the radius? Now, people with experience in 3D printing, I think I could just use supports and it would hold up these two corners because they're not radical radiuses, but you did the part that I wanted to make sure I could understand. And I was wondering if that's how you would do it, is kind of build some side sketches, and looks like that's the trick. And the only thing that I would need to add is a couple of holes on each of the tabs to hold it into the bank. So somebody shaking it hard wouldn't pull the plug out. You know what I mean?
Yeah, I'm not sure what material you're using. Yeah, I did one
3D printer PLA.
PLA. Okay.
And I'm only making that little lip 1 millimeter, so it's real small, thin.
Yeah, I did a couple different designs, and yeah, after I got your file, I went in, looked at your parameters, and adjusted my design to be to follow most of your parameters as well.
Yeah, looks good. I like it. I'm going to turn on my camera so I can eat my hamburger without embarrassing myself.
So here's a different version I did with. If you look here, I've got, actually it might be easier to see from the front. I just got a little arc bump around the outside to act as like a snap fit retainer. But when I did that, I cut slots in the side because the rectangle wouldn't compress well. But in this case, if the PLA has any flexibility to it, it can just flex a little bit as you're popping that in. Okay.
Well, it's clear to me you have significant more design experience thinking through all this stuff that I don't.
It's, yeah, I'm hoping that I can help you guys with experience in the areas I have, and since I'm learning from a lot of you guys as well on the experience you have on the 3D printer itself, the woodworking equipment, finishes, all kinds of questions I have for you guys as I go with my various wood projects. So good learning, sharing makes learning all around. But yeah, I'll send you these, and if you have any questions, if anybody else has little projects like that, please feel free to send them. I like having something that's relevant to things that people are doing here. Does anybody have any questions specific to this?
Yeah, if those arches were the same, could you just co-plane the two surfaces?
If this and this,
yeah,
in your sketch, you could make them concentric if you did them in the same sketch.
Yeah.
Yeah. Or there's a number of other tricks you can do if that's the case. Sometimes I'll use what's called a, oops, I didn't mean to do that. I'll use an axis. So I'll define an axis and then use that axis as the center point for arcs in more than one sketch. That's another way to do it. Construction features, whether they're construction lines, planes, axes, points, are very, very useful. So they're virtual geometry that helps us define our design intent in the part, but aren't actually a physical part of the component itself. Okay. Anybody else have any questions on this or anything else that you've been playing around with, looking at before we get into the meat of the evening? Anything else you want to hit me up on?
Well, Tim, I just want to say thank you. And by the way, learning that parametric design, I mentioned that I had that router table that I was putting together. That was like amazing. I mean, I had different slots, different data widths, things I wanted to do. And all I would do is go in and change a parameter, and the whole design would change with the shelf lengths and everything else. Now, the first time I did it, I found that everything changed except for one drawer that I built. So I had to go back in and look at the constraints and everything else and figure out what it was tied to so that it would move together. Once I did that, it moved together. Same thing with this plug. Was I tried to use all parameters so that if I wanted to change the width or length, the lip and everything changed with it. So the use of those parameters are, for somebody like me that never used them before, mostly SketchUp, That is amazing.
Yeah, it makes it a little more complicated to learn, but they are incredibly powerful. And I think I mentioned one time before, I did a very complicated industrial liquid storage system with cables and piping and valves and a whole bunch of different stuff. And I made it very top-down, parametric. It was right about the time that I was getting ready to teach a top-down design course in Pro Engineer. So I made the maximum use of those tools to learn them well. And it paid off, because partway through, somebody came back to me with a change in requirements, and I had to make the whole thing, I don't know, 100 millimeters wider or something. This is something big. It had like a 55-gallon drum inside it. And it was pretty straightforward to go in and change a parameter, and pretty much most things changed. There's a technique we use in design, particularly in parametric design, called flexing. Flex your design. And what that means is, when you build a parametric model, it's good to go in, and particularly if it's something like you were saying, drawer sizes, multiple different components that rely on those parameters. Once you've got your design, you think your design is pretty much there. Or even sometimes as you go, verify that the parameters are doing what you want them to do. We call it flexing the design. So you go in and go, what happens if I increase this dimension by 50%? Does it do what I intend it to do? And when you do that, you'll maybe find something that doesn't, and then you can go, aha, I missed something, and clean up your design and keep doing it. And when you're done, you have a good solid parametric design, and then yeah, you can do different sizes, different variants, tweak it as you go, as you learn things, as you make it fit. So it's very powerful. Okay, anything else? You probably recognize this. This is the model I used 2 weeks ago. I haven't really added much to it, but this is my simplified model of the Ortur laser engraver. A lot of components still missing, but the fundamentals are there, and it was adequate for us to look at assembly and joints last class, and this time I want to look at animation. So if you remember, we set up a bunch of joints, and I thought I was doing this in advance of animation, which I hadn't really learned very well yet. And it turns out that they're actually somewhat independent elements. But we designed this as 4 sub-assemblies. So we can slide the laser module up and down. It's got limits. We can go in and animate this model up and down. Looks like there's some error in the limits on that one, but that gives you the basic idea. We can animate it moving back and forth on the X axis. And then, there might be a better way to stop it. I'm using escape to stop the motion because it just keeps going. So, like myself, most of you probably assumed that this is a precursor to animation, and it's obviously kind of a form of animation. But the animation functionality in Fusion 360 is independent of joints. It doesn't recognize joints. So that's good and bad. It's good in that you can go in and do animation, exploded assemblies, etc. in your models, even if you haven't captured all your design intent in joints. If you've done a lot of design in place, it still works. It's bad in that you might want to use animation kind of as a verification of your joint design and of your mechanical, kind of like a mechanical simulation. So when you go to the animation workspace, you get a slightly different user interface. What you'll see here in the browser, you'll see the components and the component tree. You know, the sub-assemblies will pop up there, but there's no bodies, there's no features. The timeline's replaced by an animation timeline. In the animation timeline, if you've played with any of the video editing software like Filmora, or I forget what the Adobe one is, my wife uses to make videos, but it's a little bit the same in that you have this animation timeline down here where you can add and remove elements. The first thing to note is there's something called a storyboard. Now a storyboard, down here you can add storyboards. I've got 4 of them in here that I built earlier today, and each one is its own animation, and you can make them sequential, or you can make them from scratch. And I'm going to show you what these are, and then we'll go through and we'll actually make one as well. So we go through the exercise of making it. The first one I did is movement. So it's based on animating the movement of these components. So when I did the movements, I grabbed a component or multiple components and did what's called a transform. In this case, I did a transform component, and I moved it in X, Y, or Z, depending on which component it was and what I was trying to demonstrate. And you create them down here in the timeline, and we'll see in a little bit how to do that. Once they're here, we can edit them. We can move them to a different sequence. We can change their duration. We can change, if we edit an action, for example, we can change how far it's going to move. In this case, it's an 80 millimeter move. We could change that in the X direction. But once we have the animation in place, we can also animate the camera behavior. And sometimes we do this without actually intending to. I'm going to get rid of that one. So right now, when I'm moving things around, it's actually capturing some of that. If we store the time pointer here, the playhead, if we store it in what's called the scratch zone here, then if we come around here and move things around, it's not captured. Or if we turn off the camera. Right now the camera's kind of on. But if we have it out here where we're doing things, and then we move some of this stuff around, it will assume that we meant to do that as part of the animation. So that's a little warning. So again, I'm going to delete that. And I'm just going to show you this video. So in this video, we exercise the Z, the X, and then the Y. And we change the viewpoint all within the same little animation. Okay, so that's one purpose for animation, is to show how something works. If you looked at any of the videos that I tagged in the post I made today, one of them, the first one is doing an exploded assembly, which we're also going to do here. And the second one was actually doing an animation of a toy, in that case, a toy helicopter. There is a tool called Auto Explode, where you explode an assembly, and it's of marginal utility. If your assembly is pretty simple, you might be able to use it and maybe edit a little bit after the fact. But what this looks like is, in this case, I did it by subcomponents only. And in this case, I did a full, whoops, let's go back to the beginning there. Let's go right back to the beginning and let's do that again. So now it's zooming out to make room. It's exploding all the parts so that in theory you could use this for an assembly drawing or a parts list or something like that. The problem is that where it puts things automatically is rarely where you really want them to be in a good exploded assembly view or good exploded parts list. And
Do you
again,
have
you
the
can,
ability to move those around after it
what's that?
explodes? Do you have the ability to move those around once it explodes?
Yes, you do. You do. So, for example, you can come in. You can find your part here, and then do a edit action. It's going to come up, and you can change it. And say, I didn't really want it there. I'd rather have this piece for some reason or other way over here. Okay. And now it'll save that as the new desired exploded location. And when you rerun the animation, that's where it's going to put it.
Okay.
That's not a particularly good place. That was just to show you how it would work. What you're more likely to do is, I find, especially if you're wanting to do something accurate, exact, or detailed, is you'll want to do a manual explode. So in a manual explode, in this case, I'm doing a couple of things. I'm turning off everything except the laser carriage assembly, and then exploding the components of it. Now, of course, you might say, hey, I thought you said it's for an assembly purpose. That looks like disassembly. And you're right. Interestingly enough, if you right-click on the storyboard name, you can hit reverse the whole storyboard. And then when you run it, everything happens in the opposite direction. So it's pretty basic. That's the key part of it. That's what the videos look like. There is an annotation which is not that useful. I did use annotations here, and in Fusion 360 you can click on them or roll over them and see what that annotation is. But once you create the MP4 file, none of that happens. You just have these silly pins, stick pins, push pins around that don't do anything for you in the video. So I'm going to create a new storyboard, the same thing you would do with a new, if you came in with a new drawing or new assembly, you would automatically start with the first storyboard. So let's add a storyboard. And the question is, do you want it to be clean or start from the end of the previous? So this is, like I said, you can make your storyboards consecutive or not. Let's start clean. And now here's my model. And I'm going to put this in the scratch zone because I want to move this above the storyboard, the animation timeline here, because it gets in the way. So there are a couple of things we can typically do. So let's say we want, in the first 2 seconds, let's do something. What do we want to do? Well, one of the things we could do is we could go to a front view. Okay? So now our animation consists of moving to that front view. Having done that, later when we've made a bunch of other changes, we can move this action to a different time, this camera action to a different time, We can make it longer. Etc. So we have a lot of ability to change things after we've done them the first time. So I actually can't see much in this, so I'm just going to delete that camera action for now. I'm going to go back here, and I'm going to say that in the first we'll do the animation routine. So in the first second, I'm going to take the laser carriage assembly. I'm going to right, so there's a couple of different ways I can do this. I can right click and say transform component, or I can come up here under the transform menu and transform components. There's even a shortcut key M in this case, which I guess is kind of like move. So let's transform this component, and we can either do it manually, like any other move, or we can type it in here if we know exactly what we want. And the transformations can be X, Y, Z, or rotating about the X, Y, Z, not about the axis, but in an angle around there. And if we're rotating and it pivots somewhere we don't want it to, let's say, for example, we wanted to pivot about the x-axis, and we put in 30 degrees, and we said, well, that's not what I wanted it to pivot around. What's it pivoting around? It's pivoting around basically the base of the laser, and I wanted it to pivot around something else. I can come here to set pivot and find something, some place I want the pivot to be. And now when I go to the X angle and put in my 30 degrees, and it crunches. Oh, it didn't work actually. It didn't do what I expected it to do. Somehow I didn't get that pivot in the right place. Let me see why that is. This transformation here, if I set a pivot, oh, it broke the two actions. It broke the two actions. That's kind of interesting. Pivot has no meaning when it's X, Y, and Z only, does it?
So when it does this, it's not compliant with any, or you're not restricted in any movement, any legal movement of that component within the assembly.
Correct. That's a very, very salient point. You can crash into things, you can go through things. It has nothing to do with the joints. It has nothing to do with reality. It's blindly following what you tell it to do.
Okay.
Okay. So maybe I want to move that back down in another second. So I'm going to come here and I'm going to do that transformation, except this time I'm going to go, come on. It's the set pivot. I've got to figure out a little better how that works. But I'm going to go minus 10 in the Z direction. So now when I run my animation, something went weird. Something went very weird here. What happened?
Instead of going in Z, it looked like it went in Y or something. Or
Yeah, that set pivot, I did something wrong with the set pivot, and I'm going to delete and redo that part because that set pivot messed things up for me. And I'm also going to do a little faster while I'm at it. Let's go to half a second, and let's do it this way. We're going to say transform. We'll grab this guy, and we're going to do 10 millimeters in Z. And then we're going to do another half a second. And we're going to transform, and we're going to do -10 in Z. Okay, and now when we run it, it's just going to pop up and down. So kind of showing us that that's possible. Now, next, I'm going to take 2 seconds, and in those 2 seconds, I'm going to move. I'm going to transform, but this time I want the laser carriage assembly and the laser mount assembly, and I want them to move out to here. Okay. And sometimes it does a weird thing. So you got to watch this thing. It can't always be trusted. So this did something that it shouldn't really be doing, but you need to catch this. So when we run it, it's going to go up and down, and the carriage moves before the laser does. And when you look down here, you see on the laser mount timeline, it started at the half second in rather than the second in. So a couple things you can do. One is you can come here when you're down to the 2. When you have the 4 arrows, that means you can move the whole thing around. But that's not really what we want. If you go at the 2 arrows, you can now move the start, and you can do the same thing in the finish. The other thing you can do is you can hold your Apple or Control button, select them both, and then say duration 1, and let's do this again, and we should be able to align end time. Now they're aligned. Now they should move together. I'm going to come here with another second. I'm going to grab this guy and this guy. I'm going to transform. I'm going to slide them back to there. Say OK. And then, since I'm having so much fun with that, I'm going to bring it out here so we can kind of see what's going on with the rest of it. Now I'm going to come out with the next second. I'm going to add to this the X-rail assembly. I'm going to transform all 3 of these in this direction. And again, just to show you, there's no physical reality. There's no, we had limited the joint there. It's not limited to the joint. So we can do this. And when we play it, you can see the actions we did. Blindly following.
So can you tell me what the difference is between the simulation and the animation?
So simulation is something entirely different. So simulation is really should be called analysis. So it uses a technique, a computer technique called finite element analysis, and it gives you the ability to analyze when things are going to break, or how heat transfers on them, how they vibrate. So it's really an engineering analysis tool, simulation is.
Okay.
It's not something I would typically do with woodwork. So that's the motion part. And then, oops, I just made a camera action. So accidentally, but let's use it. So when we do this, see that camera action where I zoomed in and out? That happened there. That's not what I really want though. What I'd rather do is let's go to the top view now. Okay, and zoom out so we can see it all. Okay, so now if we play it, that's what it's going to do. And again, we can take this camera action and put it in a different location, change its duration, and now it'll do that on different timing. And when we're done with it, we can publish the video. We can choose the current storyboard or all storyboards. It'll just chain them all together. We can pick video resolution. And we say okay, it'll take it 15, 20 seconds. It'll sit there and crunch away, maybe more depending on your animation, how complicated it is, and generate an MP4 file. And the MP4 files are actually pretty good. They're much smoother. You see how jerky the animation is here? It takes a little bit of time. It computes it on the cloud. But let me, where was it? We don't need that. We need this one here. Let me bring it over here, and you can see what it's going to look like. You see that's a much better resolution. Smooth motion. It's not quite render quality, but it's pretty good. Okay, let's see here. Where are we?
Did I miss what you were saying about the belts? Or have you figured that out yet?
I haven't.
You
didn't miss anything. I did.
It's going to be tricky.
Yeah, they're a little trickier. There is if you go to the Autodesk website, there is a demo that includes a belt. And I had looked at it back a few months ago when we started this exercise. And we started looking at Fusion 360 and haven't gotten back to it yet. But yeah, I want to do the belts as well at some point. And I was thinking too, what I should do is put either some kind of tread or spokes or something on those little wheels and show them moving just to be more complete.
Now, do you have like a real simple drawing with maybe 2 or 3 parts that you can just show us from the very beginning when you come in to this screen, how you do it?
Yeah, you know what? Why don't I just bring in the, well, let me do a new storyboard. And what I'll do is I'll just, actually, let me cancel this. Let me go back to the design workspace, and I'll just simplify this by turning things off. So I'm going to only have this element here, which has a few components. Okay? And we'll do the exploded approach, which is very similar and related. So we'll go to animation, and I'm just going to do a new storyboard so we don't, so this would be like we just came in from scratch. And now I'm going to do what I would more typically do, which is a manual explode, where I'm specifying what's going on. So if we go to manual explode, and I'm just going to look at this guy here, and it's more than 3 or 4 components, but a lot of them are kind of paired together. So at this point, I want to explode basically almost everything. I don't want those guys, I want these guys. So all these guys here, I'm going to explode. And what I'll do is, I'm going to explode them in Z. Whoops, did I get something I didn't want there? These guys here. That's the problem with using part numbers. Let's cancel that. Let me figure out which ones those guys are. And meanwhile, let's zoom in a little bit. We'll get that guy later, but oh, that's these guys. Okay, so what I really want to explode is from here, oops, from here up to here. Come on. Why? Oh, wrong button. Shift is what I need this time. Up to here. And then when to add in the fan and the lens. Okay, so these are all the elements I want to explode. I'm going to do a manual explode in Z. And I'm going to play with the explosion scale here a little bit. And it's done something, but it's not quite what I want. So I can either do this and edit it, or I can do them all one at a time. If I do them as a group, now where did those screws go? Those screws are inside there. Now what I can do is I can come along on any element here, and I can come down here, find the elements, edit the action, and drag them to where I want them. And they'll update. Okay. In theory, they'll update. Did I hit the wrong button? Edit action. Come on. It's not playing nice with me. 100. Okay. So if you want, that's one way you can go about it. Things are a little slower tonight. It might be streaming video in another room eating up some bandwidth here. Since Fusion 360 uses a lot of server calculation, it is affected by bandwidth. I'm going to undo the explosion and delete the camera action so that we're starting over from scratch. And I'm going to try and do a little closer to what Howard was asking for. Let's try and do this a little simpler. So what I'll do is I'll start with these 4 screws. I'm going to manually explode them in this direction. My explosion scale is going to be up somewhere like this. And I have a couple of options here. You'll notice something called the trail line visibility. Sometimes when you see exploded drawings, you see the little dashed lines that indicate where elements came from. That's called trail lines. We can choose to turn those on and off, and we can edit them later as well. The other thing we can do is do it as one step or sequential. In this case, we'll do a one step, and later we'll look at sequential. I'm going to say OK. And now those 4 elements were all created in here. So now when I do my video, up go the screws. I'm going to do add another second in here. And during this second, I'm going to grab this guy here and manually explode him. Again, same thing, just coming at it a different way menu-wise. And it's a little bit flaky. You think you can grab it like a move, and you should be able to, but instead it uses this explosion scale. And for some reason or other, it's quite the scale here. That's not really what I want. So I'm going to edit this action. And instead of 12, let's drag this baby up to about 100 and say OK. And so on. Now I can go, actually, I didn't want that to be right there. Let's move that over so it's between second 1 and second 2. If we want to, we can make it really slow. Or if we want to, we can make it quicker. So now I'm going to say in the next more or less 1 second, I'm going to grab these spacers here. So I'm going to do a shift and grab all 4 of them. And I'm going to say manually explode in the up positive Z direction. And this time I'm going to use sequential explosion so you can see how that works. And say OK. And now, see, it put them in, but it spaced them out 1 second each. So now when I do the animation, screws go up together, but the, whoops, those guys aren't doing, so the first one did what it was supposed to do. These guys didn't really do it. So it flakes out a bit. So you come in here and you edit, and you say, what's going on? This should be 50 millimeters, let's say, okay. Ah. Now this one here didn't. Oh, it did. You know what happened? These are in line, the front one, the back one. So this one looks like it's the back one, hasn't gone anywhere, but in reality, it's the front one. So when we turn it, we'll see that actually they did explode. So let's, I'm going to move this camera change back here so we can see that happen. Make sense? And that fundamentally is animation. It seems like a really complex subject, but it's a fairly simple one.
I have a question.
Fire away.
Okay, so I'm kind of a chaos monkey. What happens if you change your design? Does the animation stay the same?
Let's try it.
Like if you, okay.
That's a very good point. Let's go back to design. And in this design, what I'm going to do is I'm going to go to laser carriage assembly. I'm going to come down to these spacers here. These two spacers I'm going to delete. I'm not going to save this, so I'll do that and we'll see what happens. Now, let's go back to, I've got warnings. It's complaining, probably because other components reference them. But let's go to animation and let's run this animation again. Yep. Those guys
So
are
it
just missing.
Yeah, okay.
And there's only one spacer down here on the timeline. Good question, though. Because chaos happens when we work. Does anybody have any questions, suggestions, thoughts on the animation? Animation seems really complex, but it's actually simpler than a lot of the modeling is.
Well, if it doesn't respect joints, then it probably doesn't respect other components that you.
Lost part of your statement, but yeah, it doesn't respect other components that it loses. It can crash into components. You know, it can explode one part right into another. They can exist in the same place in space. It's very, very simple, very basic animation capability. Basically, move or rotate. And I mean, you can, when you put the moving and rotating together, you can do some interesting things. The second video in the post that I made today on the bulletin board basically says, or has an example of somebody with a toy helicopter, and they spin the rotors as they move the helicopter up. And so you can do all kinds of animations that look like they're linked and play with the timing, turning cogs, turning gears, moving belts. But in reality, you have to manually make sure you synchronize things. So if you have a big cog and a small cog, then you need to rotate them. You need to figure out the rotation. It's not going to simulate it for you.
Tim, is it possible to add any annotation to that? For example, like remove these 4 screws first, and then that text goes away, and then it's remove that top plate. And then that text goes away, and then it's remove these spacers.
I would love that. But unfortunately, there isn't. The only thing I've found is the animation bubbles like this one here. And basically, you put them in, and then you get the pop-up when you mouse over or when you click on it. and there's no way to put titles on or anything like that. The only way I know to do that, you create the MP4 and then you take it into Adobe, what was it called, Director maybe, or I use something else. What's the tool I use? Somebody suggested to me. It's called Filmora. And then, you know, edit it external to Fusion 360. It doesn't have that ability to put good 3D annotation on a video. Now, that begs a question as to what level of annotation is possible. I don't see any annotation features.
And once you get the video of the object, you could bring this into other video editors and add your own, you know, annotation
Yeah.
and stuff like that to it.
It's unfortunate. I'm not sure about SolidWorks. I know Pro E, you can put 3D labels on things. And so in design, in animation, they come up and follow whatever you've attached them to. But I don't see that capability here.
Okay, thanks.
You're welcome. Any other questions on animation? On anything else? Anybody with show and tell?
I have a question basically on the animation. You said there's storyboards. You can create multiple storyboards and they're saved with the design file?
Yeah, they're saved with the design file. And when you go back to the animation workspace, you'll see the multiple storyboards down below. So all the storyboards that I did earlier today and the 2 that we did tonight are still in here, and they'll be saved in here. Now you notice that even though initially in these earlier storyboards we saw all the components, because in design mode we hid them, turned off their visibility, they disappeared from view. Oops. They disappeared from view in the animations. Now I went and turned them back on. And then when you publish, you can actually, if you select all storyboards, it'll just make one long video with all your storyboard animations in them.
So everything that you want to animate has to be a separate, what do you call all these?
Component.
Components, yes.
Yeah, you can't animate bodies within a component. So now we have two levels of components. You know, I have these, what I call sub-assemblies, and each of these sub-assemblies has multiple components. And I can either animate the sub-assembly as one element or an item within them.
Okay.
So I can grab this guy and transform him as one subassembly, or I can grab one element within there and transform him And let's say I want to do it out this way, just the single component within the subassembly.
Okay.
But what I can't do is I have to define them as components, not as bodies. Okay. Okay. Nobody's got show and tell for us?
We're coroned out.
Did I miss a video when you talked about, did you show how to build cut diagrams or anything yet?
How to build cut diagrams? I didn't.
Okay.
I didn't.
I've been doing some research on that, and I saw a couple ways to do it, but I'm not ready to demo something like that. I just
Okay.
was wondering if I missed it.
Nope, that's I'm looking for subjects for future sessions as well. If you have suggestions, things you'd like to know more about, do you want to know more about working with assemblies, or do you want to know more about importing things, or do you want to know more about creating complex shapes?
I think more about complex shapes.
Okay. Well, one thing I was thinking for a lesson soon would be lofts. We did a little bit of sweeps, and I'll look and see how complex the sweeps are. If they're just simple sweeps, then we've kind of done it, but I can go over it a little bit again. But lofting, we really didn't get into.
So complex shapes, when you talk about that, you're talking about different shapes. Like when I asked you, how do you actually make that curvature, and then you had a dress. So if that's what Howard and you guys are talking about, that's what I struggle with, is how to take a shape and, you know, you called it a draft, well, the taper or whatever. Mm-hmm. What each of those kinds of shapes are and what you can do with them, I would agree with that. Complex
okay.
Shapes.
Yeah. Maybe I'll go back. I mean, we did, you know, extrude is pretty straightforward. Right. Revolve, we know. Those two are the basic ones that we use 90+% of the time. But sweep, loft, rib and web are useful, more in plastics design.
So where was the draft you talked about?
Draft is a modification.
Okay.
And basically what draft is, it's take a vertical surface and apply an angle to it, taper it. And
look, can you do that with a cylindrical surface too, or is that called?
Yes, you can do it with a cylindrical surface as well. And the primary purpose for draft, or the historical purpose for draft, is in mold making, so that you can extract the part from the mold itself. Because the only way the part's going to come out of the mold is if you can get some clearance in there, and so you need a taper so the part can drop out of it. That's kind of the way I understand draft.
Okay.
But yeah, we can look at some of the more complex creation features and some of the more complex modifications as well in the future. Good. Anybody ready for happy hour?
Yep.
Yes.
Good. What's everybody drinking?
Modelo Especial.
Excellent.
Moscow Mule.
Nice. Moscow Mule. Oh, that's one of my faves, and I haven't had one in a long time.
Trader Joe's makes a good ginger beer. It's a little bit crisp, so it works well.
Yeah, it's got a good bite. I like that one too. My brother recently got me into whiskeys, so since I don't smoke so I don't want to have a cigar, this is the closest I can get to it. It's pretty much drinks like a cigar. And, I'll have to show you something. What my brother did that got me into the whiskeys was we do an advent calendar in December. So we have 25 2-ounce bottles with different samples between 12 people. And so we go through one every day of December, from December 1st to 25th. Making me surprisingly more religious than I was before. But it's been a lot of fun. It's the second year, but he's a woodworker. He's much more of a woodworker than I am. So I'll show you the sample box that he made.
That's a much better advent calendar than I've ever had.
So to you guys out there that do 3D printing, if I could show you, let me see if I can get this.
Can you share the screen? Can you share it so it gets bigger?
I'm kind of putting it there. I 3D printed this. I spent an hour calibrating this printer to try to get it to be accurate and not so stringy, and it's still strung like crazy.
Okay, hold it up again. He made you big now. So what is it?
Wow,
So,
it is.
oh, this is a wheel.
That's I was gonna say.
This is a wheel for an RC car. My brother, who's a machinist, just found he's getting into RC cars a little bit and asked me if I could do a 3D print one for him. So this particular stuff came out really bad. I mean, like I said, I spent like an hour calibrating this thing. And then I just got sick of it after, and each one takes 3 hours to print. So then I went ahead and said, screw it, I'm going to take that out. Let me try this other PLA that I got, better brand. I've talked to some people. I've got one going over here that's printing nice. And this one came
Look at
up.
the difference. Yep.
This one came up. I did no cleaning on this one. This is how it finished.
You know, that's what I found out recently, Doug, is the PLA can make a big difference, it seems like.
Yeah, the inland PLA is what I used before. Before COVID, I used inland, and I hadn't printed for probably a couple years. And then COVID came around, and I'm just like, okay, I need to get plastic. Inland was what I was getting from Micro Center, and they must have changed their mix because it prints like crap now. And then I went ahead and talked to some buddies, and they said, oh yeah, Hatchbox is what I'm using now, and I could get some.
Hatchbox is what I use.
Yeah, made a hell of a difference. But one of the reasons that got me to go get my Moscow Mule was that I went to turn my light on so that you guys could see me, and it glitched my Raspberry Pi and stopped my 7-hour print at about 6.5 hours. I'm like, damn.
We feel your pain.
It's like, yeah, it must be plugged into the same circuit, and it's a fluorescent light. I don't know, it glitched it. And so, yeah. Fun with 3D printers.
When you say calibrate your 3D printer, what does that mean? Because, I mean, you can do the bed adjust is all I know about, because I'm not that familiar with 3D printers. I use it, it prints cool, and I'm happy, but I know I'm going to have problems. So what is, I've heard you use that term about calibration.
So yeah, so I mean, we're doing, we're building parts, 3D parts that have to fit together and stuff. So if you're going to use, and this is what I use my 3D printer for a lot, is making parts that fit together. I mean, they have to be the right size, and the holes have to be the right diameters.
Right. So how do you calibrate something?
So what I did, I have created a few objects, and you can find some online, but I've created some. I use OpenSCAD. I could probably use Fusion 360 now. But I create these little objects that I make the walls, the thickness of the walls, the thickness of what I set my slicer to. So I've got a 0.4 millimeter nozzle, and I tell it that I want it to print 0.45 millimeter wide lines. You always want it just a little bit bigger than your nozzle. So what you want is when you go ahead and print, you want those lines, when you tell it that those lines are 0.45, you want it to print 0.45. And so what you do is you start printing this, and then you go ahead and get your calipers out and you measure how thick it is. And if it's short of 0.45, I go into my slicer's multiplier, my extruder multiplier, and I'll add like 5 thousandths of a millimeter to the extruder. So it's extruding just a little bit more.
So you do it with your slicing software.
You tune you're tuning your slicer so that it's sending the right data to your, so there's that. And then like I put holes in this, and the reason for the holes is because it stops and goes across, so that generally you only have to adjust your temperature. So what you'll do is you'll try to get your temperature low enough and your part fan speed set up so that the plastic cools and doesn't string across. That's one thing. There's also something called retraction, because the way the 3D printer works is it's the plastic's under pressure while it's printing, so it mushrooms as it lays that line. Like I said, the nozzle is 0.4 millimeters, and you're saying put a 0.45 millimeter wide line. So it's going to be slightly mushroomed, and it's going to make a little pancake, shaped line. And and it's under pressure. That's how this all works so accurately. But when you then go ahead and say, oh, move to the other side of a hole, all of a sudden that pressure is just going to ooze out, just give you a big blob. So there's a setting called retraction.
Right.
And retraction, what it does is it will go ahead and turn your extruder backwards a certain amount, and your filament is almost like a syringe seal, so that when you pull it back, it causes a little bit of a vacuum and a suction and pulls the plastic back into the hot end. It allows you to move it, get to the other end, and then it unwinds that and starts again. So that's another way to tune it for, and that's why I spent an hour with, almost a dozen of these printing these out to try to get it so that it wasn't stringing. And but that's, yeah. And then you just find out that, okay, it's just like this plastic needed to be quite hot, in order to get it to not skip and to squeeze out. And that was just, it was too viscous. It just would not pull back up, and just.
Well, it sounds good. I didn't want to hijack the meeting. I just had a quick question because you asked that. Maybe I'll call you if I have more questions.
Well, I just figured lots of you guys are 3D printing stuff, and
I looked like Tim was going to show us something though, as I hijacked it with a question. What were you going to show?
That's okay. No, this was more.
Advent calendar.
Yeah. So
I had a question for Doug. Are you using the Prusa slicer, or do you have some other software?
I went through a bunch of the slicers when I first started doing this, and I preferred the slicer with the 3R, SLIC 3R. That was the slicer I went to because it had a lot of options to tune, and I liked that. And I found out that eventually I found out that Prusa was using slicer, and then Prusa started really putting a lot of effort into updating it and giving it some nice features. So I went ahead and I was using Prusa slicer, or it was originally called, anyways, yeah, I'm using Prusa slicer, even their latest version. I
So
don't have their printers though.
So we might have equivalent software at the shop that you're talking about with these features to jump over a gap.
Yeah. Travis likes the Prusa 3D printers, and I believe he uses the Prusa slicer. So yeah, these options are in the advanced setting, I think, on that slicer.
Okay, thanks.
Yeah.
Anyone else got anything?
When I did that inlay seminar this weekend,
Yeah.
and I on the final piece, I cut it in half so you could see how it sets actually in the wood. If you'd like to see a picture of that, I can turn my screen on and you can see what that looks like.
That'd be great.
Nice. Yeah, that'd be great.
Let me share my share screen. And you got a host disabled screen sharing.
Oh, wait, I got to give,
How were inlays done before CNCs? The guys that did it by hand, how were inlays done? Because you would think that,
long,
today,
hard work.
yeah, this amazing stuff I've seen over the years. It just looks so damn easy now with a CNC.
Okay, can you see the screen?
yep.
So
Wow.
you can see, I mean, this is, I don't know how you can get any tighter.
No, that's great.
Wow.
That's incredible.
And it don't matter how thin they are, how thick they are, that, you know, they all translate quite nicely.
And all the details on how to do this are in the video from the class you did, right?
Yep. Oops.
Cool.
Yeah, I actually used Howard's when I did that. You guys saw those cheese boards I did?
Yep.
With the
Yeah.
cheese boards, I used Howard's handout when I did that because that's what Travis handed.
And it worked first time, right?
Yeah, worked the first time. Yeah, that was I had a one that was a little deeper or something, so I played with the 1/3 part just a little bit. It was a deeper inlay, and I'm not sure I needed to, but I just wanted to see what it did. But yours worked perfect the first time.
You know, when I posted it on YouTube, I had a couple people come in that were like the experts, and they were saying, "Oh no, you can't have it down there tight like that. You got to do this, got to do that." And I said, "Well, it just works, you know. I mean, maybe there's a better way. I'm sure there is, but you know, there's a lot of different ways to do it. But I tried a bunch of different ones, and none of them ever worked. And you know, this started working, and you know, they look good. They stay together, and I don't see any reason to do it any other way."
Yep.
And the gluing is always easy as well.
I'm sorry, what?
Is it easy to glue? I mean,
yeah.
it seems like that's the thing that's the hardest part to get just right is you really have to clamp it or something really tight, right?
Well, yeah, I use a C-clamp on my
really?
workbench,
Okay.
and that's plenty. I mean, it's actually very easy to glue because
Mm.
you're basically gluing two pieces of wood together that are fitting. You're not putting all those little pieces in individually. And if you watch the video, you can see exactly what I'm doing. You can see how it fits together and it's tight. And then you just put the clamp on it, and 40 minutes later, you're
Have to do
cutting it
that.
apart. And
As
Finish
close
it.
as these fit with the CNC and how tight those fit, it's probably a good thing that there's like a little bit of a gap for the blade. You know how when you fit,
well, when you use that method, it does leave a gap. That's why like the
Yeah.
female is 3/3.
right, 3, 2, 1, right?
Yeah, 3, 2, 1. And that gives you that gap so you can have a bandsaw blade not touch your wood and cut that top piece off.
And that probably also lets some of that glue come out too. As tight as those things are, I would think that, I mean, if some of this wood is hard wood and it's not going to let that glue, you know, I mean, you almost have a hydraulic issue.
Right, but
That's what I was worried
by
about.
having the hydraulic issue, it's forcing the glue up into that gap.
Right.
Yeah.
That's yep.
Now, one recommendation a guy gave me that I found was pretty good He said, yeah, I spray mine with shellac before I glue it. That way, if the glue that comes out onto the good piece doesn't soak in. You know, I figured, yeah, it's not a bad idea.
So one of the things I did change, Howard, a little bit, and that was to make my technique easier, was the gap where you put the bandsaw through. I added a little more distance to that, so I didn't have to be so precise with my bandsaw. That's the only thing I changed from that.
Yeah, I made this one big table for a neighbor, like 24 inches round. I put the inlay in there and I carry it over to bandsaw. It's like, well, what the hell was I thinking? I don't have a 24-inch bandsaw. So then I had to mount it back up on the CNC and mill the top down.
Yeah.
It all worked. That's all I got.
So you can take it, you can cut it off with the bandsaw, you can take it down with the CNC, or I mean, I guess you could arguably take it down with a planer.
No, the planer would probably be, well, you possibly could, but good likelihood you're going to tear it out.
Yeah.
Yeah. If you have a drum sander, you can use a drum sander, you know.
Yep.
But the best bet is what Howard talked about, bandsaw and then use the drum sander.
But if you got a CNC, you're gonna, you know, you're not gonna try to sand 3/8 of an inch of wood.
No, you're gonna use a planer bit and use a CNC.
Yeah.
Yeah, and I suppose if you made it on a CNC and it's 2 feet, it's got to fit it back on the CNC.
That's right.
Yeah.
Not everybody has a 2-foot diameter CNC, so.
Or a big bandsaw.
Yeah.
Cool. Well, gentlemen, anything else?
What was you going to show us, Tim?
Oh, I was just going to show you the sample box. So this is what I want to do an inlay on, actually. So this is what the box looks like that my brother made. It's walnut with maple dividers.
Mm.
And
you could easily do the Howard's inlay in the top of that box. It would look awesome.
yeah, so I just want to take a piece of walnut and some maple to do the inlay and figure out what to put on there in terms of design. That's the tough part is figuring out the graphics. I say that not having done inlay before.
I'll tell you what, some of the best designs I've seen is that you go to Google and you do that tribal art, and there's all these designs. They're very easy to convert to vectors. Some of them are already vectors, and it's nice looking stuff.
That's an interesting idea.
And if you really want to surprise your brother, you could go ahead and inlay in text describing what each part is on the inside of the box.
Well, the thing is, we refill it every year with different blocks.
Oh, okay. Yeah, it doesn't work.
So the idea is to reuse the box and fill up the bottles every year. But yeah, I'd like to personalize it for him and make it a little fancy. So I'll do one for myself, and then having figured it out, do one for him as well.
If you wanted to bring that over like some afternoon or whatever, we could whip that out in probably 2 hours.
That'd be kind of cool. Like I say, the graphics part is what's going to be the challenge for me, I think, figuring out what it is I want to put on. Tribal art's a good one because he has some native experience. He lived on a native village in Canada for 5 years, so and spoke the language. So something that is in the Ojibwe art area would be kind of cool. I hadn't thought of that before. I like. And
if you even knew the name of the tribe or whatever, you could probably Google that and maybe find out some original art from that where he was at. Yeah. He has a few paintings that he bought that are original art in that area, but that's usually fairly colorful. But I can come up with something. I hadn't thought about the tribal art thing at all. I really like that suggestion. I think I'll find something there. Yeah, when you start looking at that stuff, it's like, oh, I like that one. Oh, I like that one. You know, and they're basically 99% of them are free.
Right, right. And you just download and either trace them or they're vector to begin with, and then.
Well, you just take them into VCarve or Aspire, and literally 30 seconds later, you got perfect vectors to do your inlay.
Right, right. Cool, cool. Love the suggestions.
And that video I did, we took it all the way from going on to Google, downloading the art, converting the art. It went from the very beginning to the very end of that whole project. So,
what kinds of wood have you mostly used for it?
I like using sapele. I love using dark walnut. Wood, and you got to be careful what wood you use for the mill part, because like you can't use oak because it's too stringy, and all your finer pieces will just kind of disappear on you. You can use the oak for the female part, but you can't use it for the male part and get a good result. At least I couldn't. But like maple is a real good one for the male part because it's a hard enough wood and it takes a nice cut and line, so it's very crisp. Poplar is a good color, lighter color one.
I heard beech was pretty good too.
Yeah. It might get a little soft, and then I found if I lower my speed on the male part, I can take off a lot more than I should, like when I'm doing the V-carve on the mill. But I find if I lower that down maybe about 30%, 40%, I get a much cleaner finish cut. And, it doesn't take that long anyhow. It's only like, 5 minutes to cut the mill part. So now you're looking at 6 minutes instead of 5.
So Sam, your discussion about beech, that's what the 3 of those cheese boards were made out of that the shop were beech. So they worked good on the female side, and the male side, of course, was that Claro walnut, as Howard said, the walnut works well. So that was a good combination. At least at the pocket side, the beech worked real nice.
Yeah, it's mostly the wood. The wood you want to use is pretty homogeneous, and not too much stuff that crumbles and or stringy, like Howard was saying. I think.
Yeah.
By the way, on Fusion 360, Tim, I have on my screen what my final cut diagram looked like on that router scan thing. If anybody's interested in seeing how you could put a cut list, it's tedious, so I need to work on it and learn how to do it better. But did you want me to share what it looks like? Cut diagram versus cut list.
Yeah.
So I'll just share a screen here.
Hey, Howard, can you give a host to Rob?
Do I have the host back?
I gave you host.
You gave me host. How do you give the host back?
Go over and click on Rob. Find your participants tab.
Okay. Oh,
and then find Rob and say, click on it and make him host.
More.
Oh, actually, I can reclaim host. Never mind. I didn't realize I could do that. Hang on.
I already gave it to him.
I think.
Okay, I'll hit share. Oh, it's still disabled.
There you go. Now you should have it.
Yeah,
okay, you are host now. Okay, so right here is what the final, can you see that?
Nope.
Now you got to share screen.
Oh yeah, I had to.
There you go.
Can you see it?
Hit share the second time, yeah.
Can you see it now?
Yep.
So that's what the final version of this router thing I'm building that goes in. It's a Rockler router stand, and I'm putting a cabinet inside of it. And I was struggling with how do I actually find out how to cut the plywood. This is 3/4 inch right here, and this is 1/2 inch for drawers. And I wanted to be able to lay it out. And so the one good thing about this method is you have this cut list, and then you can use, remember Tim going over the drawing tab? So you can take this out to a cut list with the parts and the sizes that you put it in the property and so forth. So that works out. That part works out really well. It just takes a while to get everything from your stand over here. And then what you can do is, if you see I'm moving the timeline back here. So as you move the timeline back, all your pieces go away. But you can get back to the point. So you don't even have to make a new drawing. You can make a new drawing and save it with just the cut list, or because you went through and moved everything, you can just move everything back to where they were originally. You can see my stand building over here in the corner.
Mm-hmm.
So
So
once you get back to that point, turn off the plywood, and now you're back to the point where you actually had your stand to begin with.
so you just disassemble your model.
Yeah, I just disassembled my model and put it on a plywood stock. That's a separate. Notice I made them separate components so you can turn them on and off.
So is that an easy thing to do, to orient and move them around on the plane?
It's somewhat easy. I can show someone if they want to, but it's time consuming. That's the thing that's frustrating. It's
Yeah,
easy to sketch up. But in this, I figured I watched a video on how to do it and it worked well. And of course, the nice thing is by having the I put the stand parameters inside, so I knew when I made my sketches and stuff, it would fit inside the stand. And that interesting thing is, I'm going to take the stand off for just a second. What we were talking about before, which I thought was just awesome, the cat's meow, I said, was if you go to these change parameters, for example, I wanted to know how much room I could have on the sides of this cabinet to be able to put router bits and stuff in. So if I wanted to change that, I just go in here, for example, if I wanted to make the spacing smaller so I have as little as possible and have bigger drawers in the middle, I just came in here and changed this parameter that you can see, and I put like 8 between the spacers, hit OK, and next thing you know, I've got these great big sides. Did you see how that changed?
Yep.
And then if you take off the front drawers, let me take the faces off. You can see the drawers and sliders and everything inside changed. And all I did was go in there and change the one parameter to say I wanted the dado places put somewhere different. And you'll see it'll change right back now. See how they made them smaller now? And the drawers got big?
Yep, that's the idea.
So that's an example of how you can get to a cut diagram. And in the cut list, you already showed us before, Tim, which is using the drawing feature. And you can do the same thing with the cut diagram. Once you get to a cut diagram, if you make that your view, after you moved everything over, then it will actually take that view and put it on that drawing and have all the pieces you can diagram out. It just takes a long time.
It does. That's the thing I was kind of disappointed with.
Yeah, you've run into that too, Sam?
Yep. You know, I want to have dimension drawings so I could take it in the shop and make something, right? And so to get there after you have this model is still really time consuming. So
yeah, it's almost as long as it takes you to draw the model.
Yep. Yeah, I agree. Now, do the drawings don't follow when you change the parameters, right?
Yeah, actually they do. That's the cool thing.
The drawings?
Yes. So if you make a drawing, and I'm going to do one over here. It's messed up because I totally messed it, but let me put this drawing up for you.
There's a little update button you got to hit though, right? Up to the top.
That's what I was going to show you. So here's a drawing. You see this warning down here, and I'm not even sure how well the drawing will pop up because I made so many different changes. Okay, you see that drawing? There's a cut. See, there's a cut diagram.
Right.
So I think it'll fall apart here because I made so many changes, but we'll see. So see this little button up here has an exclamation mark. Can you see it on your screen?
Yep.
If you click that, it's telling you that it'll now, your reference drawing has changed. And if you change that, I see it messed up because I changed it so radically. I changed it back and stuff. So it's going off the view you're looking at the time. So it changed everything because it's trying to point to the same components, which are now back in the box instead of the cut diagram. Remember, because I replayed the timeline back. But if I left it where it was and I hit update, any changes I made to that cut diagram would have shown up on here.
Okay, well, I'll try that.
I'm not going to save it. So, anyway.
Yeah,
Oh, thanks, Rob.
I gotta think about whether you could make a second design that used the same components.
Well, if you can duplicate it and
Yeah.
then
Yeah.
you know, if you make changes to one, it makes changes to the other, and that's the one that goes to the drawing. And I don't know.
I did that at first. I actually made a copy of what I thought was my final drawing, and then I took that all the way to the cut diagram, like you're suggesting.
Mhm.
And so then I thought, well, that's cool. I got everything I needed. Well, then I started thinking about some design changes I wanted, so I had to go back. I either changed that one, the one I did the cut list, or the other one, and I decided, well, the guy showed me how I could go in the timeline. Like if I wanted to update that cut list now, that cut diagram, it's not a list, it's the diagram. Cut list is separate. If I wanted to do that cut diagram, I could have fast forwarded all the way back to where I was. You saw how I reversed it.
Right.
Then it would have updated right. It's
And
just
you can save different iterations too. So
yeah, it just helps with the time. It helps learning how to use that timeline.
yeah.
Hey, so can we start a GoFundMe page so we can get Doug some light bulbs?
Something that's not fluorescent.
Just got to plug that in somewhere else.
Yeah.
Not a bad idea, Howard.
No,
Good time to move from fluorescent to LED.
Yeah, that's what I think.
There you go.
so a while ago, I was looking to put a little UPS, a little battery-powered UPS on my Raspberry Pi, because I thought it would just be really handy to have. And I had tried where is it? I have a small battery charger, like you would use to, like, you charge that up and then you can plug your tablet or your phone into it and it will charge those. So I thought, well, those are cool. Those are cool because you could just plug the charge into that and then plug the Raspberry Pi on the output. And I found one that would stay plugged in. Lots of times when you plug in the charger, it turns off the output. But I bought one that would stay on. And the pisser was that it didn't put out more than like an amp when it was plugged into the charger. And the Raspberry Pi, in some cases, you know, I got 2 3D printers off this Octopi. And so it wanted a couple amps and it didn't cut it. But that would have solved my problem because it would have been this, you know, to handle the brownout. Anyways, that's geeky stuff.
They got those plugs they used to use for the stereo that would give you real good clean power.
Oh, they're filtered, yeah.
They're like filtered, and that might be something, you know, would work.
For something like this, yeah, I can't imagine that nothing else blinked or surged. So something with a simple little filter on it might have worked.
How about a real UPS for a computer?
Yeah, but that's kind of big.
Yeah, it is big.
Something that big.
It is big.
For this.
Not only that, but listening to Doug over the last few months, if you can buy it straight out, he's not interested in it. He's got to build it.
Or if you have,
usually stuff doesn't fit what I want. You know, they come close, but it usually doesn't fit. Or when I find it, I'm going, oh well, that could be done better.
Hey, I've got some lead fishing weights and some acid. You could build yourself some batteries.
Oh, there's some cool stuff on building batteries. Yeah.
Speaking of building your own, I've been trying to buy a webcammer for about 2 months now for this one computer that I'm usually here watching, and you just can't buy them for love or money except for the little cheapy ones. And I bought like 4 of those. I've had to send all 4 back, and then I found that Canon made a utility now for their cameras, so you can use your Canon, you know, like 7D or your, you know, there's like 20 or so of their cameras that they have. You can use it as a webcam now with this utility, which is what I'm using right now, and it works way better than the webcam was working. And so far, so good.
Yeah, the picture is really clear.
Well, yeah, you're dealing with, a single lens reflex with, $1,000 lens. I got to get rid of that hobby. Sell all these lenses. That was my get away from woodworking and the dust hobby. It's like, oh, geez, photography is kind of clean.
So I don't know. Let me try bringing this over. My brother's got a coffee shop he's trying to start up, and he also has like a bunch of old cars parked there that he works in, and he needed a way to see it from home to make sure nobody was stealing stuff. So he started showing me these webcams, and I started looking them up, and then I found this IP camera here. See, I don't like the cloud. If I can have something that I can control, that's cool. The cloud is a good option, but I also, if the cloud's not there, I want to be able to access it remote, locally. And so this was $45. It's got a pan tilt, and it's got the pan tilt thing on it. It was $45. It's HD. I went ahead and checked the network traffic. Found it was going home, even though I thought I had turned it off, and it was going home. Researched it. The company who made it has a page to tell you how to turn that off. And it's pretty, if your web camera, you just want to be able to see it like in a browser. This one's pretty darn good for for $45. I was like stunned that it's got, even the tilt and zoom and stuff on it.
Does it have infrared lights for night?
It does. It has infrared. The web page lets you set up whether it's automatic or if it turns on those features at certain times.
You mean it has a web server built in for controlling it?
It's got a web server built in. It has a slot. It's got a slot for an SD card, so it stores locally. It even has on the camera the capability to set up areas to trigger for motion, and it can track. If you wanted to, if it sees motion, it will then it'll follow that motion.
Wow.
But Doug, you can set up multiple of these cameras on a system or something?
Yep.
Yeah, they would all have their own IP address. If you didn't want to use I think their cloud has free service for basic stuff. But essentially it would have its own IP address that you would set it up to connect to your router. And then you would have to look, you'd have to go into your router config and tell it to like keep that IP address. So that way
you have to make it static. Yeah.
Right.
And that comes in handy when you're like either doing a 3D print or you got your CNC machine working and you don't want to set out in the garage for 9 hours. You go in the house, sit on the couch. Yeah. I've got the camera mounted right above the CNC machine, and I can sit there and watch it and listen to it. If I hear any noise that shouldn't be there, or if something breaks loose, I'm out there in 10 seconds or less. Yeah. Very convenient.
Yep.
What was the brand again, Doug?
This one is Amcrest.
Amcrest 1080p.
Amcrest.
Yeah, let me go ahead and I just bought it. Within the last couple of weeks. Let me just go to my Amazon page, and I could probably get you a link. That was crazy how inexpensive that was.
So have you used it?
I'm surprised that you were able to buy it with the shortage of cameras.
It's mostly like the kind of cameras that are short are the kind for video conferencing. Not really security
Webcams.
cameras, I think.
You can still buy a
We need
security
because
camera.
we're all at home all day long.
Right. Okay, so let me go to chat. So there it is in the chat window. Yeah, $44.99.
Cool.
Crazy. It has Wi-Fi. I haven't tried Wi-Fi yet. I plug it right into my router. It's kind of that's how I was able to monitor its IP traffic and make sure it wasn't phoning home. I mean, it's not like I've got stuff to somebody would want to steal. Stringy plastic wheels, you know.
Yep, that's true.
Awesome.
Okay.
Yeah.
By the way, Ken, I did find out that there is a Fusion 360 app by which you can go in and look at your designs off your iPhone or iPad.
Yeah, they have an app for everything.
Yeah, the phone app's pretty cool for like looking at stuff offline. Obviously, you don't want to be doing design on your phone, but for showing it around and stuff, it's kind of cool.
So, for example, like if you built that cut diagram or a cut list, and you didn't want to take around the paper all over the place, and you had an iPad
yeah, you
with you
could
or
take it into
something,
the shop with you. Yeah.
you know. Well, gentlemen, I'll see you later. My better half's calling.
All right.
Yeah, I think,
All righty, I think
are we
we're
pretty
done
much ready
here.
to wrap it up, guys?
Yep.
Sure.
Yeah. Thanks,
Thanks,
everybody.
everybody. It's great seeing you all again.
Thanks.
We'll,
Thanks, Tim.
we'll talk to you in 2 weeks.
All righty.
Sounds good.
Thanks a lot.
Thanks. Ciao.
You bet. Bye-bye.
Ciao.